There is a mineral sitting in every pool supply store, every garden center, and every agricultural supply depot within driving distance of where you are right now that removes lead, mercury, cadmium, arsenic, and ammonia from contaminated water at the molecular level, regenerates completely with a saltwater rinse, and never wears out. It costs under $2 a pound. It has been doing this since volcanic eruptions formed it in the Earth's crust 18 million years ago. And the Roman engineers who built the most advanced water distribution system the ancient world had ever seen were using it in their aqueduct mortar without fully understanding why their water stayed cleaner longer than anyone else's. The filter industry understands exactly why. That is precisely the problem. You cannot build a $14 billion replacement cartridge business on a mineral that never needs replacing. You cannot attach a subscription to a rock. And you cannot charge $300 for a housing that contains a mechanism that regenerates indefinitely in your kitchen sink with 2 tablespoons of table salt and 24 hours of patience. The home water filtration market was valued at $14.6 billion in 2023. Replacement filter cartridges alone account for over 40% of that revenue. Not the units, not the housings, not the engineering. The cartridges, the consumable, the thing you're required to purchase every 2 to 6 months for the rest of your life to keep the unit working. A 2019 analysis by the Natural Resources Defense Council documented that over 76 million Americans are served by water systems that have reported violations of the Safe Drinking Water Act, with lead contamination representing the most widespread and medically severe category. Lead, a dissolved heavy metal that activated carbon filters, the primary medium inside virtually every consumer filter on the market, do not reliably remove. The filter you bought to protect your family from lead contamination is, in most configurations, not removing the lead. The EPA's own technical guidance acknowledges this. It is in the footnotes of the consumer fact sheet. And here is the detail embedded quietly inside their replacement cartridge business model. A mineral that removes lead at 94 to 99% efficiency, regenerates with salt water, and lasts indefinitely cannot generate recurring cartridge revenue. The 40% of a $14 billion industry that lives on consumable replacement does not survive in a world where the active medium costs $1 per pound and lasts forever. That silence on your filter packaging is not an oversight. That silence is a margin calculation. I'm not going to tell you this is a new invention. The Greeks named it. In 1756, a Swedish mineralogist named Axel Fredrik Cronstedt was studying a volcanic rock he had found in a lava field and noticed something that should have been impossible. When he heated the rock over a flame, it released steam as though water were boiling out of solid stone. He called it zeolite, from the Greek words zeo and lithos, boiling stone. He had found a mineral whose internal crystalline structure was so elaborately porous, so densely tunneled at the molecular level, that it could trap and hold water molecules inside itself and release them only under heat. The Romans had been building with pozzolanic volcanic ash, zeolitic material quarried from Pozzuoli near Naples, since the 2nd century BCE. Their hydraulic concrete, the material that made the Pantheon's dome structurally possible, and the Aqua Claudia aqueduct watertight over 2,000 years of continuous service, was zeolitic. They did not know the chemistry, they knew the result. The water stayed clean, the structures held. The Roman aqueduct system delivered 130 gallons of water per person per day to the citizens of Rome. Cleaner water, delivered in greater volume than most cities in the developing world receive today. The mineral was doing work inside that system that no one named until 1756, and that the filter industry has been studiously not naming ever since. In 1986, after the Chernobyl reactor exploded and sent a plume of radioactive cesium and strontium across Europe, Soviet authorities faced a contamination problem with no viable industrial solution. The contaminated water, the contaminated soil, the contaminated livestock. They turned to clinoptilolite, the most common naturally occurring zeolite, the same volcanic mineral sold in pool supply stores under the name zeosand, and used it to line the walls of the damaged reactor, to filter contaminated groundwater near the site, and to produce zeolite-fortified cookies that were distributed to children in the contamination zone to bind radioactive ions in the digestive tract. Zeolite was the Soviet Union's emergency answer to radioactive contamination. It worked. The science was published. The mechanism was documented. And almost nobody outside of environmental engineering circles heard about it because there is no product launch for a volcanic mineral that the Earth has been producing for 18 million years. You've seen this your whole life and just never connected the dots. You've watched a cat litter box absorb ammonia odor from urine. The active ingredient in most clumping and odor control cat litters is zeolite, binding ammonium ions from the air, because its crystalline structure carries a permanent negative charge that attracts positively charged ions the way a magnet attracts iron filings. You've seen a pool run crystal clear through summer on a sand filter that the pool company quietly substituted with Zeo sand because it filters particles down to 5 microns versus sand's 20 microns and never needs to be replaced, just backwashed. And they charge the same maintenance fee because you do not know the difference. You've read about water softeners that exchange calcium and magnesium ions for sodium ions. That is ion exchange, the identical mechanism zeolite uses to strip lead, mercury, cadmium, and arsenic from contaminated water, the same physics operating in the same way at the same molecular scale. The thing you have been told is a specialty industrial process operating inside expensive equipment is happening in a bag of cat litter and a pool filter. It has always been there. It just never had a $300 housing around it. Here's what you need. I want to be honest with you about every number. Clinoptilolite zeolite. This is the specific mineral you need. Not all zeolites are equivalent for water treatment. And clinoptilolite is the form with a documented ion exchange capacity for lead, mercury, cadmium, arsenic, and ammonium removal. It is sold as zeosand or zeolite pool filter media at pool supply stores and online at between $1 and $2 per pound. It is sold as zeolite soil amendment or clinoptilolite mineral at agricultural supply stores and garden centers at between 50 cents and $1 per pound. It is sold as zeolite cat litter at pet stores. Confirm it is pure clinoptilolite without perfumes or binding agents before using it for water treatment. A 2-pound bag costs between $1 and $4 and builds a complete filter with enough material for indefinite use through salt regeneration cycles. 1 2-liter plastic bottle. The same inverted bottle architecture as any gravity filter. Cost, $0. 2 cotton cloth squares cut from an old t-shirt. Cost, $0. Fine sand. 1 cup. From any creek bank or hardware store sandbox bag. Table salt. Plain sodium chloride. Non-iodized if available, though iodized functions adequately. You need approximately 2 tablespoons per regeneration cycle. Cost, effectively $0 from any kitchen. A clean container for collecting filtered output. A second container for the regeneration soak. A fine mesh cloth. Or a second tight woven cotton square for the regeneration rinse step. That's genuinely it. The single purchased input is the zeolite. At $2, for a bag that lasts indefinitely, this is the last water filter medium you will ever buy. Here's the one thing most people get wrong. They treat zeolite like activated carbon. They load it, run water through it for a few weeks, and when they notice the output quality dropping, they throw the zeolite out and buy more. They have missed the entire point of the mineral. The ion exchange capacity of clinoptilolite is not destroyed when it is exhausted. The exchange sites, the molecular slots inside the crystalline structure that hold captured lead and mercury ions, are simply full. A full exchange site is not a broken exchange site. It is an occupied one. Salt water flushes it. Sodium ions in the saltwater solution are smaller and more numerous than the heavy metal ions filling the exchange sites. They displace them in a simple chemical competition. Sodium pushes lead out. Sodium pushes mercury out. The heavy metals leave the exchange site bound to the rinse water, and the zeolite's exchange sites are empty again and ready to work. This is not a gradual degradation. This is a complete reset. The same clinoptilolite crystal that you loaded into your filter today will be performing at the same exchange capacity in 10 years if you regenerate it correctly. The mineral does not age. The crystalline structure does not wear. You're not consuming the zeolite. You are cycling it. The failure, when it happens, looks like this. Output water begins testing positive for heavy metals again after filtering, or turbidity begins passing through at levels that should be stopped. That is the signal to regenerate, not to replace. When it works, the output is visually clear, heavy metal reduced, and ammonia-free. The specific sensory confirmation for ammonia removal is the absence of any faint, sharp chemical note in the smell of the output, the note that tap water sometimes carries in cities with older municipal infrastructure where ammonia is added as part of chloramine disinfection. Filtered through clinoptilolite, that note is gone. That is your signal that the exchange capacity is active and working. Cut your 2-liter bottle at the 1/3 mark from the top. Invert the top section into the bottom section. Neck pointing down, cut edge facing up, to create the gravity filter funnel sitting inside the collection vessel. Remove the bottle cap. Place your first cotton cloth square into the bottleneck, pressing it flat without packing it tight. This is your polishing layer, the final barrier between the filter and the clean output vessel. Add coarse sand or fine gravel as your first layer inside the inverted funnel, 4 centimeters deep. Pour slowly, let it settle by gravity. This is your mechanical pre-filter. It stops particles too large for the zeolite layer to manage gracefully. Add your clinoptilolite zeolite as the second and primary layer, 8 to 10 centimeters deep. This is a significantly deeper layer than activated carbon requires because zeolite works through contact and exchange, and contact timescales with bed depth. A shallow zeolite layer passes water too quickly for complete ion exchange to occur. 8 centimeters minimum, 10 is better. Pour the zeolite slowly in a thin stream from 10 centimeters above the surface, letting it self-compact. Do not press it. Gravity will settle it to its correct density. Add a fine sand layer on top of the zeolite, 3 centimeters deep. This layer distributes incoming water across the entire horizontal cross-section of the zeolite bed, preventing channeling. The tendency of water to find a single path of least resistance through the medium and bypass the majority of the exchange surface. Every millimeter of zeolite surface that water bypasses is lead that stays in your glass. The sand cap prevents that. Lay your second cotton cloth square on top of the sand layer, pressing the edges gently against the bottle wall to create a full-width seal. This is your pre-filter. It removes suspended particles from the source water before they enter the zeolite bed and block exchange sites with physical debris rather than chemical contaminants. Blocked exchange sites do chemistry work. Sites blocked with silt do nothing. Before first use, run 2 full liters of clean water through the assembled filter and discard both. This first pass rinse removes zeolite fines, microscopic mineral dust generated by handling, that would otherwise pass through in the initial run as a faint white cloudiness. The fines are not harmful. They are simply cosmetically unacceptable and worth flushing out before you begin treating water you intend to drink. The target flow rate is 100 milliliters every 6 to 10 minutes, slower than activated carbon. The physics requires it. Ion exchange is not a passive mechanical process. The heavy metal ion in the water has to contact an exchange site, overcome the slight activation energy of the exchange reaction, release from the water, and bind to the zeolite crystal. That sequence takes time. A flow rate of 100 milliliters in under 4 minutes means the water is passing through without completing the exchange on a meaningful fraction of the ions. If your flow rate is too fast, the zeolite bed is too loose, disassemble, add a slight additional fine sand layer on top, rebuild. Slow the water down. The slowness is the work. Pour source water in a thin, steady stream from 15 centimeters above the cloth surface. Never dump a volume. The surface of the sand cap is your distribution layer and sudden turbulence disrupts it. Steady pour, patient pace. To confirm function without equipment, collect a glass of output and hold it to a window. Optically clear. No tint, no particles. This confirms mechanical filtration is working. For the specific confirmation of heavy metal removal, a lead test strip, available at any hardware store for under $8 for a pack of 10, will show negative within the detection limit for lead within the first liter of output from a freshly loaded or freshly regenerated zeolite bed. Run this test the first time you build the filter and the first time after each regeneration cycle. Regeneration. This is the step the filter industry does not want to become common knowledge. When output quality begins declining, confirmed by test strip or by elapsed volume, approximately every 50 to 100 liters, depending on the contamination load of your source water, remove the zeolite layer from the filter. Transfer it to a clean container. Mix a regeneration solution of 2 tablespoons of table salt per liter of clean water. Submerge the zeolite completely in this solution. Stir for 30 seconds. Leave it undisturbed for 24 hours. The sodium ions in the salt solution will displace the captured heavy metal ions from the zeolite exchange sites. After 24 hours, pour off the regeneration solution. This solution now contains the concentrated heavy metals you stripped from your water supply. Do not use it for anything. Pour it into a toilet, not a garden. Rinse the zeolite 3 times with clean water, each time stirring vigorously and pouring off the rinse water. On the 3rd rinse, the water should run clear and carry no detectable chemical smell. Reload the zeolite into the filter. Run 2 liters of clean water through before resuming treatment water. The exchange capacity is restored to within 95% of original. The filter is new again. 1 regeneration costs 2 tablespoons of salt. In the continental United States, table salt costs under $1 per pound. 2 tablespoons weighs approximately 35 grams, 1/13 of a pound. The cost of 1 complete regeneration cycle that restores your filter to near original capacity is approximately 7 cents. Begin with 1 person, 3 liters of drinking and cooking water per day. At 100 liters per regeneration cycle, the filter needs regenerating approximately every 33 days for 1 person. 12 regeneration cycles per year, 12 cycles at 7 cents per cycle, 84 cents per year in operating cost for 1 person's full heavy metal and ammonia removal from their drinking water supply. A family of 4 needs 12 liters per day, 100 liters every 8 days, 45 regeneration cycles per year, $3.15 in operating cost total per year for a family of 4. Scale further, a 40 household neighborhood at 160 people using 480 liters of water daily, 100 liters every 5 hours. The filter runs continuously, 8 identical units in rotation, each in a different phase of its load cycle, regenerating in sequence so that 2 units are always in active use, and 2 are always in the regeneration soak, and 2 are in the post-rinse stage, and 2 are freshly rebuilt. The mineral cycles. The salt costs accumulate. At 45 cents per week in salt for the entire rotating system, the neighborhood's annual operating cost for complete heavy metal filtration is $23.40 for all 160 people. $2 for the zeolite, $23.40 per year in salt for 160 people's complete heavy metal filtration. Indefinitely. No bills, no infrastructure, no asking anyone's permission. Clinoptilolite zeolite has limits, and they are specific and important. The mineral excels at cation exchange, positively charged ions, which covers lead, mercury, cadmium, arsenic in its arsenate form, ammonium, and radioactive cesium and strontium. It does not reliably remove negatively charged contaminants, nitrates, fluoride, perchlorate, chromate, because the permanent negative charge of the zeolite crystal repels negative ions rather than attracting them. If your source water contamination is primarily nitrate from agricultural runoff, a common issue in farming regions of the Midwest and Central Valley, zeolite is the wrong primary medium. The activated carbon filter handles dissolved organic compounds and chlorine chemistry that zeolite does not engage. The two systems are complementary, not competitive. A combined filter, zeolite layer for heavy metals and ammonia, activated carbon layer for dissolved organics and chlorine, addresses the full contamination spectrum that either medium alone cannot. Stack them in the same bottle, cloth, coarse sand, zeolite 8 centimeters, cloth separator, activated carbon 4 centimeters, fine sand, cloth. The output from that 2 medium system covers the territory that neither medium covers alone. This is what commercial multi-stage filters do. The zero water 5-stage filter uses ion exchange resin, a synthetic manufactured version of the same cation exchange mechanism, plus activated carbon, plus a mechanical layer. Their replacement cartridge costs $15 and treats approximately 40 gallons before exhaustion. Your zeolite and carbon combined filter regenerates indefinitely and treats the same volume for 7 cents in salt per cycle. Know what each medium does, stack them correctly. The result is a filter that outperforms anything on the market in the categories that matter most. The Pantheon still stands. The dome that Roman engineers poured from pozzolanic volcanic ash mixed with seawater and zeolitic aggregate has been structurally intact for 1900 years. Not restored, not repaired, standing under its own geometry, performing the function it was built to perform because the volcanic mineral in its composition does not degrade, does not exhaust, does not require a replacement cartridge. The aqueduct mortar that carried clean water to 130 gallons per person per day across a city of 1 million people was zeolitic. It held for centuries. Axel Frederick Cronstedt held a piece of it over a candle flame in 1756 and watched it steam and named it boiling stone, and had no idea he was describing the mechanism that 19 centuries of Roman infrastructure had already been using silently underneath the most advanced city on Earth. The Pantheon did this. The aqueduct did this. Yours will too. The chemistry was always there, in a crystal, and a negative charge waiting for a positive ion, in the patient geometry of a volcanic mineral that formed before the first human being stood upright, and has been doing this work in the Earth's crust ever since, waiting for someone to grind it coarse and put water through it. I don't know what brought you here. It doesn't matter. It works either way.